Okay, my name is Katsuhito Sudoh from at National Institute of Science and Technology. I'm going to talk about the type of paper with this long title, the focusing on the human and automatic MT evaluation. I'm focusing on the critical error problems. So it's really related to today's Lucia's talk. That she said she said catastrophic errors, translation errors. I think that it's really related to my topic. Okay, let's go. So the quick overview of this work is illustrated in this slide. So this is an example from Japanese to English translation. This is the sentence from the patent ones, and this English translation is correct. Then, but if we missed one word, if we missed the word not, so the meaning is completely different. So this causes a serious misunderstanding by these meaning errors. So this kind of errors often happens with the actual machine translation. There are another kind of translation errors can be seen in this way. So terminals each other and do not contact to be placed. This is grammatically incorrect. We cannot understand the meaning of this sentence. So these two kind of critical errors can be observed in the actual machine translation. So my point is to evaluate these translation errors in the classification-based way. So in my way, so the left translation errors is the labeled contradiction, and right-hand one should be labeled incomprehensible in this way. So the point of this work is to revisit classification-based evaluations. Actually, it's highly motivated to the traditional ones using the adequacy of fluency. So the background of this work is the recently used the regression-based MT evaluation. So this is founded on the human direct assessment. The recent MT evaluation work almost based on this human direct assessment. So using the DS scores, the standard scores, and the recent work with the BERT regressor and the BART score and the BERT use this kind of regression-based one. So, but I have a question about this one. So can they identify critical errors shown in the previous slide? So these are some artificial examples. So from the WMT data set, the first line is the complete the same as the reference from. It got very high scores also for BRU and BART score and the BERT. And the next two sentences is the completely different, have a completely different meaning from the original sentence. But the BRU and the BERT score gave very high scores on these wrong translations. And the BERT also gave the 0.6. The BERT can identify the second one. The error in the second one. It's a complete the negation flip. So the last two lines means that have different meanings. The first one is the kind of word salad. The last one is a completely different meaning. This is the acceptable sentence, but the meaning is really different. So the most the BRU and BART score and the BERT the penalize these wrong translations. So research objective of this work is classification-based machine translation variation that can identify the critical errors in meaning and comprehension. So I'm going. I focused on the two-dimensional ways, like the traditional ones, fluency and adequacy. But the fluency, in fluency, I also consider the comprehension problem. And also this work is based on the sentence. not just a segment level. So this is proposed by the Popovich in the last year's workshops and the last year's conferences, Conrad Koring. So the difference of from that her work is our work is sentence based. And I am focusing on the human and automatic evaluation, not just for human evaluation, but based on the newly developed new human evaluation corpus. I also try to automatic evaluation. Okay. So this is the array of my human evaluation. So I chose this set from WMT metric tasks, some a bit old ones, the 2015 to 17. There are about the 9,000 MT results in English. And I asked the English development company for the 3 English annotators. They are native speakers of English and they had work experience in translation to English. But then I didn't conduct specific training for the annotators. So the evaluation was conducted in a monolingual way. That means annotators can see only empty results and corresponding references. They are not familiar with the source language, so I conducted the evaluation in the complete monolingual way. So the annotation, the evaluations are completely independent among annotators. The annotation corpus is now available under the following GitHub. Okay. So there are 2 evaluation criteria for the first one is fluency, including comprehension. There are 5 categories: incomprehensible, poor, fair, good, and excellent. This is really similar to the traditional fluency metric, but somewhat have the different definitions from the original ones. So the right side is the adequacy criterion. So there are 7 categories: incomprehensible, unrelated, contradiction, serious, fair, good, and excellent. The first 4 categories are for the very critical errors. The first one is incomprehensible translation. The second one is unrelated translation, like the last sentence in my artificial examples in the south right. And the next one is a contradiction motivated by the natural language inference. The serious means other kind of serious errors, critical errors in the adequacy. Okay, so I gathered the 3 annotators, 3 evaluated evaluation results and analyzed the results. The agreement was not high about the 0.3. That here we found that among the 3 annotators, the annotator B was very strict in fluency, annotator C was very strict on the adequacy. The details of the results are detailed results is shown in the paper. Please see the paper for the details. So I also analyzed the different the relationships between the DS scores and the categories, the fluency and the adequacy categories. Here we found that for the fluency almost works at the Likert scale. So this is the kind of high point Likert scale. So in adequacy, we found some interesting things. So unrelated, or this one, they scored worst in our data, and the contradiction are scored a little bit better than the serious and incomprehensible. It's probably due to the relatedness of the contradicting translation hypothesis with the differences. They have a very similar content, but such as there are some similar serious error, such as negation flip or something. Okay. Then, so using the human evaluation corpus, I developed an automatic evaluation using the Roberta-based classifier model. So I split the data into the training, dev, and test. The test set consists of the 2017 data, the 560 sentences for Czech, German, Finnish, Latvian, Russian, Turkish, and Chinese. Okay, so then we have 3 different annotators who have to take an agreement for the training data. First take the majority of the three annotators, and then so if their judgment was split, so I take the pessimistic heuristics. Please see the details in the paper. So here's the results, automatic evaluation results used for the fluency. The accuracy of the fluency prediction was below the 60%. It's not so high. So there are serious confusion between the adjacent categories. So they're typically for the poor and fair and fair and good. So there is serious confusion for the adjacent categories. So on the other hand, the advocacy accuracy was 60%. So there are also serious confusion between this serious and fair. So the fair, good, and excellent would be acceptable translations, and the others are unacceptable translations. So this kind of confusions is very serious for us. So the automatic evaluation can be have to be improved more for the practical use. So the summary of the automatic classification results. So in fluency, the number of serious classification errors with distant categories was not so large here. The incomprehensible translations are not categorized into the good and excellent or something like that. On the adequacy, so some categories are very rare in unrated and contradictions are very rare in our data. So they are difficult to predict. And the predict of excellence seems good, and their actual judgments were mostly excellent or good. So if their automatic classifier says it's excellent, it will be actually excellent, actually acceptable translations. These are the results. So for the conclusion, so we propose a classification-based human and automatic evaluations motivated by the fluency advocacy. Those are very traditional ones. And our human evaluation was not did not have high agreement, so the evaluation process can be improved for the better agreement. So more careful evaluation instruction for the evaluators. And finally, the automatic evaluation should be improved more for the practical use in machine translation evaluation. Our future work would include the further development of human evaluation corpora, not limited to the MLMT metric task, and also not limited to the MT task, I think. The data augmentation to tackle the lab imbalance for unrelated and contradiction. The current shared task data doesn't fully cover actual MT programs. And this kind of classification can be used for MT training or fine tuning, so to improve the machine translation engine itself. Okay, that's the end of my talk. Thank you very much.